Hello, Honors Physical Science students. It's Tuesday morning, 8:30. Time to do some physical science. So we're going to pick up where we left off on Thursday. I know we were working through that packet. If you still have that packet, go ahead and get that out. If you don't, I'm posting it on Classroom. So make sure, like I said earlier, you need to make sure to show me all of your work. So make sure you show me all of that. Andrew, you know you're going to get mad about that, but get over it. I know you don't like to show work. So make sure you show me all your work. And then if you want to do it on the packet, take a picture, email me. I'm good with that too. That's probably going to be our class participation grade for the day. I have not yet decided if I'm going to send out a Google form or not with other questions. And I probably will, but I haven't done it and haven't made it up yet. So be ready for that. All this stuff will be posted on Google Classroom tomorrow morning as well. Then we're going to take some notes. You need to take notes. You can type them up. You can write them down. If you write them down, take a picture, email me. That's fine. If you do them, share them with me. That's fine as well. You are taking your own, not like 5 people doing it. Right, so you can't just all plug it in, and I know you guys love to do that. I want to see your own, okay? I don't have the skills to see you necessarily paying attention, and so you're going to do it on your own for me. Whoops, I'm not supposed to touch my nose. Going to do it for me on your own. That would be great. Yeah, so we're going to get going. We're going to do some learning, make sure we're good. You will have homework tonight as well. Hey, we don't have much left in this unit, which means tests coming up on Friday. All right, tests on Friday. It's going to be my first experience with this. So I would imagine there's going to be a multiple choice part. I imagine there's going to be a paper part, which I will probably post for you on Classroom. Yeah, I will see what that's going to look like, but you will know what that's going to look like. So I would imagine spending 45 minutes, an hour of your day on Friday taking a test for me. It will be the first big grade that we have in there. Before we do anything else, let's go ahead and let's pray to get today started. Dear Lord, you're awesome, you're amazing. And as we get started on this new adventure, one where we don't get to see each other in person less than 6 feet away from each other for a while. And as we get used to this new normal, as we get used to just what this world is going to be like for the next 3 weeks to who knows how many weeks, we just ask that you just continue to bless us, be with us as we continue to learn. Just continue to watch over, continue to bless and be with our families, be with our friends. And Lord, as I know we might be home with siblings, we might be home with parents that we're not used to being home for long periods of time. We just ask that you just continue to bless and be with us and help us and just give us the wisdom to deal with others in that way and in that situation. Lord, you're awesome. You're awesome even when times are tough, even when we're going through this whole thing that the world is going through right now. You're still awesome. You're still there by our side each and every step of our lives, and we want to thank you for that. We want to thank you for your Son, for that perfect life, so that even though things are messed up in this world, we know that we are forgiven. We know that we have that hope of eternal life with you. Lord, just help us to realize that daily. All this and all things we lift up to you in the name of your great and glorious Son, Jesus Christ. Amen. All right, so as we get going here, we're going to pick up, it's actually Conservation of Energy Packet Continued, I believe is what I named it. Like I said, I'll post it on Classroom. We got 5 problems to go over. We're going to go over those 5 problems. I highly recommend that you do this. You're going to try them, okay? So we're going to start this. I might say pause, I might not. Before we go on to the next one, try it by yourself. I will walk us through this whole thing, but try it by yourself. All right, and so we're going to see how it goes. There will probably be some of these on the homework assignment tonight as we get through. You guys know reviews coming up on Thursday, so we'll walk through that review together on Thursday. And then as we go, we'll make sure that we just figure things out as we go, because that's all we can do right now. We don't know too much else going on. You know I'm not going to change, right? So I'm pretty much doing the same stuff, different day, and over the internet instead of actually talking to you. All right, so hey, as we go through, you guys will have that time to talk to me. I want to talk to you guys almost every day, so call me. We might do a group Google Hangout and a giant FaceTime as I have my iPad. and we'll have my iPad next to me for the next little bit as well. So I want to talk to you all. I want to be able to discuss things with you if we're struggling, if we don't understand things. And so please, 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 please make sure you're asking questions. All right. So if you don't understand something I go through today, that's fine. I also don't know if you guys like the silence while I erase the board or if you don't, but I'm not pausing the video. I'm just doing this all in one take. You guys know I'm going to mess up talking because it's me. So there's that. All right. Yeah. Hopefully you don't have any questions right now. If you do, that's fine. We're probably going to finish up notes today. Probably a lot of figuring out what is going on tomorrow. And then review on Thursday, so probably not an actual necessary homework assignment except for get ready for test on Friday. All right, so that's kind of the plan as we go throughout this week. So there's that. All right, good. So without further ado, let's get going. Like I said, sometimes I'll tell you pause, sometimes just figure it out because I know I'm going to forget. Also, I actually have to plug numbers in now too, so bear with me as I actually go through and plug things into the calculator, because normally you guys do that for me, but you aren't here, and so I actually have to do everything. It's a lot of work. So I appreciate you. I miss you guys for that, and you know I miss you a ton, and that's not going to change already. So let's get going. So here we go. So we're going to start out a 59 kilogram man. Just so you know, this is actually number 8 if you just have the packet. But if you don't have the packet, that's the case. If you can't really read this, let me know. I'm going to try and figure out something else if you can't. So let's just work through. A 59 kilogram man has a total mechanical energy of 150,023 joules. So remember, as we go here, mechanical energy is just what? Of course, it is just your potential plus your kinetic. Now, remind me, potential energy, how are we going to find potential energy? We can see that up there. Oh, yeah. Potential energy, we're going to do mass times gravity times height. Our gravity, we know, of course, is 9.8 meters per second squared. Our kinetic energy, we know we're going to do 1/2 mv squared. Okay, so that's all stuff that we should know. That's all stuff that should be reviewed as we go. If he is swinging downward and is currently 2.6 meters above the ground, what is his speed? So let's just talk real quick. Right now, I know mechanical energy, we got 150,023 joules. Okay, I know the mass, of course, is 59 kilograms. I know our current height is 2.6 meters. All right, so if you want to, pause it. I think you thought that you probably paused it there for a second, didn't you? Right? So you could pause it, try it out, figure it out, and then come back when you're ready. And here I go. I'm just going to go because you guys can click pause by yourself. All right, so what I need to figure out is hey, I know that this, of course, is both your kinetic and your potential. So I know I can figure out my potential because I know the mass and I know the height. So to figure out our potential energy currently, we're going to do 59 times that 9.8, and then we're going to multiply that by my 2.6. All right, so that's how I'm going to figure out my potential energy. So as we take a look, we figure this out. Like I said, I actually have to plug things in. So we got 59 times 9.8 times 2.6. I get out 1503.32. So we get 1503.32. Remember, energies are always measured in joules. All right, so that's what I have there. Now, that tells me my potential energy, which means the rest of it is going to be kinetic energy. All right, so we need to figure out our kinetic energy. So first thing, how am I going to figure out my kinetic energy? I'm going to subtract those two values from each other. So we got 150,000 number divided by, subtracting that 1503 number. So give me 1 second to get that done. So we got 150023 minus 1503.32. If you guys notice me doing anything incorrectly, please let me know. There's a chance you guys know I can also mess up as we go. So we know my kinetic energy is going to equal 148,519.68. Okay, that of course is going to equal 1/2 mv squared. All right, I'm going to plug some things in. So we got 1/2 we got our mass of 59, we got our velocity squared. I know some of you don't like to do it that way. Some of you like to do it the other way. That's fine. I can do that. So we have 2 times our energy, which is our 14859.68. Then we said we divide by the mass, which is 59, and we're taking the square root. So go ahead and find that out. So right away we're going to do the square root of 2 times 148,519.68. Going to take that part and we're going to divide it by the 59. I get, as my answer, my velocity is going to equal, what did you guys get? I don't know what you got. I know what I got. Here's what I got. I got 70.95. So I got 70.95 meters per second. Remember, velocities in meters per second. All right. Hopefully we understand number 1. Like I said, I know sometimes I'm in the way of pictures, so if you need to, find one. Let me scoot this over a little bit, just try and make that a little clearer for you over there. So as you find a spot that you like, if you can see everything, pause it, figure it out. You should have gotten 70.9-ish. That's what I got. All right, any questions? I hope not. And so here we go. We're going on to question 2. Going to erase the board. Now, I have a couple of options that I can do for you as I erase this board. Number 1, if you really want me to, I can be quiet. Number 2, if you don't want me to, I can continue to talk and tell you what I did this weekend or tell you a lot of different things. What I ate, I don't know what you want me to tell you. You guys tell me. All right, so just because I have nothing else to talk about while I'm erasing, this weekend I rode on my bike about 40 miles and read a couple books, so that you know that was a rather exciting weekend. Went to church too. It was good. All right. Hopefully you guys got a chance to go to church, spend some time in God's Word, and now we'll be ready to go. All right, everyone good? Hopefully we are. This is number 9 if you have the packet. It is number 2 if you don't have the packet. And so here we go. A 75-kilogram student starting from rest slides down an 11.8 meter high water slide. How fast is he going at the bottom of the slide? So right now I know, hey, we got some type of energy, but I don't know what type of energy. So, of course, if we're sitting at the top of the slide, I think that my energy is going to probably be potential energy. All right, so we got potential energy here. And to find potential energy, we're going to do mass times gravity times height. All right, so at the beginning, we only have potential. Why do we only have potential? Because we are at rest. And when we are at rest, we know that we are stopped. And so if I'm stopped, I know I have no speed, which means therefore I have no kinetic energy. So when I multiply, we got 74 times 9.8 times our 11.8. I know that my total potential energy here is 8557.36 joules. Now, as I go down the slide, my potential energy is going to change into kinetic energy. And so at the bottom of the slide, do I have a height? No, I'm at the bottom. Why would I have a height? Doesn't happen. So at the bottom, I know it's all going to be kinetic, which means my total kinetic energy is also going to be that number. All right, so we're going to do that same thing. We're going to do velocity equals square root of 2ke over m. All right, so we do that. Hopefully you've been trying this and now you're just double checking and you can skip through some of the annoying part of me talking because I know I can be annoying. It happens. Okay, and so then we got 74 there. Let's actually figure this out. So if I plug this in, we have 8557.36 on top there. And on the bottom, we know we have 74. All right, so when I go there, I get 15.2. Let's see here, 15.207. So let's just say 21 meters per second is how fast we're going at the bottom of the water slide. I don't go on water slides very much, but water slides are pretty awesome. Yep. I don't know if any of you swim, spend time swimming, go to water slides. You tell me. Okay. All right. Next up, here we go. Number 3. Number 3 is easy, right? So let me scroll this down. I'm not erasing the board for number 3. All right. Calculate kinetic energy of a 750 kilogram compact car moving at 70 meters per second. Pause. Figure it out. All right. Here we go. What do we got? Kinetic energy equals 1/2 mv squared. So we got 1/2 mass, of course, is 750. Velocity is, of course, 50 squared. Depends on how much you want to do, right? You could do half 750, 375, 50 squared, 2,500, and then multiply those together. Or you could just not do anything and plug it in as it is, which is probably what I will do as I'm over here on Desmos. We got 750, and then we, of course, have our 50, and we're going to square that. And I believe that we get 937,500. So we got 937,500 joules. Should have been the easiest one that we've done so far. Good. All right, erase board time. Hopefully you guys are doing well as we are going through. We got 2 more to do, and then we're going to get into notes. I know the 5th one has like 3 parts that we need to do, but we'll get through it and we'll be okay. Before we do anything else, Jamel. I don't know what that was. That's for you, Jamel. All right. There we go. And now we should be set, ready to go, except this is probably still too wet for me to actually write on. So I'm just going to make it a big blur. All right, determine mechanical energy. Remember, how did we say mechanical energy? We said kinetic plus potential. All right, so we know, what do we have here? 450 kilogram coaster moving at 30 meters per second at the bottom of the first dip, which is 15. I don't know why this says me. All right, that should just say meters, not me. I'm not above it. There we go. Let's get rid of that. Above the ground. So I have a kinetic part. I have a potential part. So let's find both those parts. So we got potential energy equals 450 times 9.8. And I know my height is 15. I know kinetic, we got 1/2. We still got the 450. And we got the 30 squared. All right, 30 squared, of course, is 90. If you want to figure that out, half of 450 is 275. No, that's not right. 225 if we want to do that. But let's real quick figure out those 2 values. So we got 450 times 9.8 times 15. All right, so that's going to be the 66,150. That's that number. Other one, we got 1/2 of 450. And then we're squaring a 30 here. And that is going to be 202,500. I'm going to add those together. 5, 6, 8, 6, 268. Remember, that's going to be measured in joules to find my mechanical energy, because all we're doing there is adding those 2 together. So let me get my fat head out of the way. We got 268,650 joules. Great. Number 5 as we go here. So let's go to number 5, last one on here today. All right, and let's see here. I need to actually scroll it up so you can see everything. So Julie has a mass of 49 kilograms. What is her potential energy? So first thing we need to find, that's why I have that answer slot there, so we can actually find her potential energy. Then we need to find out her kinetic energy just before she hits the water and her speed. All right, so let's see what we can do. All right, so starting off, we got mass of 49 kilograms. So we're going to do 49. We know we got 9.8, and we know we're 6 meters above the ground. So if I want to find my potential energy, that is what we are going to do. So we are going to do our mass, which is 49. We're going to multiply that by 9.8, and we are going to multiply that also by 6, because that's the height. I have 2881.2 joules, I believe, is what we are measuring. Now, that's potential up at the board. If I go right before I hit the water, what's my kinetic going to be? It's just going to be all of that. So A, what is the kinetic energy? It's just going to be 2881.2 joules, right? Because your potential is just changing into your kinetic. Fine, great. Fantastic. All right, so now we're just doing the same thing we've done already twice a day, 2ke over m. So we got square root of 2 times 2881.2 dividing by that 49. So let's figure out how fast we are actually going when we hit the water. So we got square root, let's do a divide right away. Let's do 2 times 2881.2. And we're going to divide that by our 49, which is our mass. I believe we are going 10.84 meters per second. All right, so that's how fast we're going when we did that. Hopefully you got those right before you actually saw me go through them. Hopefully you tried them, and that's the case. So remember, our mechanical energy is kinetic plus potential. All right, and so as we're jumping, if it all starts potential, down here it's probably all kinetic. And as we go through, what's going to happen? Your potential is going to decrease because we're getting to a lower height. And as we're going down there, our speed is going to increase, which means our kinetic energy is also increasing. All right, so hopefully we are good on that. So now let's actually get into our notes for the day. All right, so let me pull this up quick. And I believe this is where we are, because I think we talked about roller coasters a decent amount. So we're going to be done talking about roller coasters. I'm going to review that really quickly, and then we'll be good. Hey, these, as we go, I recommend just pausing the screen. Well, you can take those notes because, of course, you're going to have to share them with me. Okay, so I would just pause the screen real quick, and then I'll talk through. And so you don't actually have to try and listen and write at the same time. You can do that on your own. All right, so let's actually talk through here. So energy can't be created or destroyed. This is the law of conservation of energy. Total amount of energy in the universe never changes, although it may change from one form to another. All right, real quick, I'm going to pull this over here so we can talk. All right, so let me actually go here. So we talked, remember the other day, Jamel came up and we said, hey, at the very beginning, all kinetic. Up here, there's no speed, so it's all potential. Over here, it's going to be all kinetic again. Going up, kinetic is going to decrease. Why am I drawing an up arrow when it's decreasing? Potential energy is going to increase. Why? As we go up, it's going to slow down. That's why kinetic energy is decreasing. Height is getting bigger, so we know that potential energy is increasing. Going the opposite direction, hey, height's getting lower, so potential energy is going to decrease, and your kinetic energy is going to increase because we are getting faster. Okay, that's if I throw a ball. We didn't talk much the other day about pendulums, but remember, pendulums, they just go back and forth and back and forth, right? It's just like, hey, let me take my keys here. Great. Pendulum. Boom, 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 boom. Fantastic. All right, so here's what we got. Up here, it's all going to be potential because it has a height. And right before it comes back down, what has to be the case? It has to stop. That's why it's all potential there. Down at the bottom, it's all going to be kinetic because am I going to consider that a height? I'm going to consider that a height of 0. No kinetic, no potential, all kinetic. Up here, it's going to be all potential again. So right now, this way, as we're going this way, keep that in mind, potential is going to decrease, kinetic is going to increase. Go in the other direction, hey, potential is going to increase, kinetic is going to decrease. But then, hey, as I go the other direction, we know that's just going to reverse and flip-flop. All right, and so we'll talk through that later on. Okay, so hopefully we got these notes down. Good. Everyone should be okay there. All right, so next slide here. We know that energy does not appear or disappear, which means just like mass. Remember, we had to balance those equations last semester because, hey, I have to start with a certain mass and end with a certain mass. I can't change that. I can't all of a sudden lose particles. Okay, same thing here. I can't all of a sudden lose energy. Is it in the same way, shape, or form all the time? Absolutely not. But I can't just say, hey, all of a sudden, all this energy is gone. Not going to happen. Okay, so energy does not appear or disappear. It's going to stay the same. We may do work to increase energy in a system. Think about the roller coasters. What do? We rode up on that conveyor belt to get to the top. And what was that doing? That was applying a force over a distance. When it did that, it was applying a work. And so now we have potential energy in the system. May transfer to non-mechanical energy. That's when we were talking about roller coaster. That friction gave off heat, gave off sound. Those are non-mechanical because mechanical is potential plus kinetic. All right, some may leak out to the surrounding environment. That's the sound aspect as well. So that's what we're talking through here. Overall, our energy doesn't change, but it can transfer forms and it can become non-mechanical. All right, so it's not going to change the total amount though. All right. So, fireworks, hey, we have energy. We have what type of energy as we shoot it off? Probably kinetic. Why? Because it's going super fast. It's going into the air. As it's going in the air, what's happening? Speeding up, slowing down. Probably slowing down because it's getting higher. As it gets higher, what else is happening? Your potential energy is going up because we're at a way bigger height. Okay? So now, what happens? As we get to the top, we have all of that potential energy. Then we hear a giant boom. That's pretty good boom, huh? All right, so we hear a giant boom. And when we hear that giant boom, there's a whole bunch of sound being released to the area around us. Okay? When we hear that giant boom, there's probably a whole bunch of heat, thermal energy given off. We also see light. So just because we had kinetic, then we had potential, that doesn't mean it's all going to stay kinetic and potential. We're giving off heat, light, sound, all that stuff. And I know I pointed to the wrong thing. Get over it. Okay? All right, so that's the case there. All right, now thermodynamics. We're going to talk thermodynamics just real briefly, and then we'll do a little demonstration as we go. I might have to move the camera a little bit. We're getting fancy here, guys, but we'll be good. So thermodynamics describes energy conservation. For any system, the net change in energy equals the energy transferred as work and as heat. When no energy is transferred this way, mechanical energy is conserved. So if I don't do any work, if I don't give anything off as heat, I know that your potential and kinetic are going to stay the same. All right, not the exact same, but when you add them together, the mechanical energy is going to be the same. All right, so thermodynamics is we're not doing any work and we're not giving off any heat. And when we do that, our mechanical energy is conserved. That's really what the law of thermodynamics says. All right, so there's that. So it's called the first law of thermodynamics. When energy is conserved that way. So when we don't do any work, when we don't transfer any to heat, we know that energy is going to be conserved. That's the first law of thermodynamics. Now, we mentioned something about systems last unit, and I want to talk real quick about systems this unit. All right, so as we look at systems here, when we're talking systems, let me get out of your way real quick so you can at least pause it and take a look. If I look at the whole world, life is difficult, right? We have so much energy to talk about that it's not going to be fun to talk about any part of it because there's so much to talk about. All right, and so what we like to do is we like to look at a little picture. For instance, if I'm throwing a ball in the air, we are just talking about that picture. If I'm talking about the pendulum, I'm just talking about this pendulum. I'm not talking about, I don't know, Zach sleeping over there, because Zach's probably asleep right now, right? I'm not talking about that. I'm talking about what's going on with the pendulum, all right? And so that's the case there. So scientists limit their view to a small area or a small number of objects because we don't want to deal with everything in the world. It's a waste of our time. Because accounting for all energy everywhere is difficult, we make it smaller. We've done this a whole bunch this year. This isn't new. So let's talk about our types of systems. All right, so we really have three types of systems. We have an open system, we have a closed system, and we have an isolated system. All right, open system. Energy and matter are exchanged with their surroundings. So let's just take a look at the classroom, right? So as I take a look in just the classroom, all right, as I look in the classroom, if I'm in this classroom, all my energy is in here, right? And the door's open right now, so what can happen? As I go here, I can go out into the hallway. Oh, look, that was easy. Oh, look, I can come right back in, right? So my energy and the matter, right? So if I'm talking energy, if I'm talking out here in the hallway, I know that people in the room could hear me if you were actually there. I know that my matter can come in and out as however I want it to. So if it's an open system, energy and matter can come in and out of your system. All right, everyone okay? Hopefully you're okay with open systems. All right, closed system. All right, closed systems are a little different. Energy, but not matter, is exchanged. So in a closed system, all right, so hopefully you paused it, took a minute to get that down so we can talk about it. closed system. Energy is transferred, but not matter. All right, so if I go here and I close this door, you will probably be able to notice something. I can't actually come in, but hopefully, and I know it might be tough to hear on the video, as I'm talking from the hallway, you can still hear me if you would be in the classroom. My matter couldn't come in or out, but the energy, the sound could. So if I have a closed system, that's going to be the case. So energy can go in or out, but matter can't. All right, so if I have that case, yes. Hey, you can hear me, but I can't come in or out of the door, even though you guys can see that. All right. Last but not least, isolated system, neither energy nor matter is exchanged. So even if I'm talking in the hallway, my energy couldn't come in the room. All right. So if I'm outside there, it's not coming back in. That's what isolated is. So isolated, nothing is coming in or out. Open, matter and energy both could come in or out. And closed, we know that, hey, energy can go in and out, but matter cannot. All right, and so that is the rest of section 3 of this unit. So hopefully we have an understanding of law of conservation of energy, closed, open, isolated systems. Hopefully we know all of that stuff, can understand, hey, throwing a ball, hey, looking at a pendulum, roller coasters, which I know we talked about last week. All right, so this is actually the last slide of notes for the day. So tomorrow, what we will probably do is we will probably spend a day and just do some review of a lot of the math type work. All right, so I will we'll probably have a document put together. We'll do one together, and then you guys will probably do some of the math by yourself as a homework assignment. All right, and then on Thursday, we will have a review that you will need to make sure to have done and turned in. And then it will also be a classwork aspect to that. Might just be like a Google form where I just kind of, hey, quiz us at the beginning. And then Friday, we know a test is coming. Hey, been great teaching you today. I know this is different. Start getting used to it because it's going to be the new normal for a bit here. Miss you guys already. I know it's crazy, but it's weird not having people shout out answers at me. It's really weird to have to find everything by myself. Miss you guys. Stay safe. And we'll talk to you tomorrow. All right, bye.